So without further ado, we are excited to welcome Erin Maloney. Thank you so much for volunteering. Um, Volunteering is a strong word. I asked very pointedly whether you would be willing to talk and gave you a very specific 1 hour time window. So thank you for being voluntold to give our second MCLS virtual brown bag. I hope that that takes some pressure off you. Anything that feels like it's pressure, just say that it's because Andy made you do this on a short notice. So Dr. Maloney is an assistant professor in the School of Psychology at the University of Ottawa in Ottawa, Canada. She earned her PhD in cognitive psychology from the University of Waterloo and has since kind of been bouncing back and forth between the northern United States and southern Canada, working as a postdoctoral scholar at the University of Chicago, and then working as a senior researcher at the Higher Education Quality Council of Ontario and as a defense scientist for the Canadian Department of National Defense. Her research program focuses on providing a greater understanding of mathematical well-being by investigating how the mind processes numerical and spatial information and how this processing can be disrupted or enhanced by various emotional states. She's incredibly passionate about issues surrounding diversity, inclusion, and equity in research and practice, and she's everything I want to be when I grow up. So a couple of brief notes. This is being recorded. We just ask that everyone turn off their mic at least and their camera if they would like throughout the conversation. Once we jump in to the Q&A portion, things will get a little bit more chaotic. We'll ask people to take their questions into the chat box, and then I will kind of call on people individually to present their questions to Erin, and hopefully we'll be able to engage in some really exciting conversation. So without further ado, thank you so much, Erin.
Awesome, thanks, Andy. Okay, so for those of you who logged on a few minutes before this started, I was talking about how I was feeling a little bit nervous. One of the reasons for this is that every time I try to do anything technological, it makes me feel super old. So I literally had my husband practice with me for a good 10 minutes this morning on how to share my screen without embarrassing myself. So we're gonna see if this works. Okay, so. All right, everyone can see the title slide. Oh, I realize everyone's muted.
Yes. Okay.
See, that's the whole technology anxiety thing coming out. I'm freaking out. I'm gonna have like a whole new field of study after this. But, so thanks everyone for logging in today. I do really, really appreciate it. And I am really excited to talk to you about a lot of the work that my colleagues and I have been doing over the last number of years. So in general, I'm gonna talk about math anxiety, math achievement, and what we refer to as mathematical well-being. So when I think about mathematical and scientific well-being, I'm not only thinking about how students might be doing on tests or sort of formal assessments of mathematics, and I'm not even just talking about how students might do on informal assessments of mathematics, right? So doing things like calculating a tip at a restaurant. We're also thinking about the attitudes and emotions that can often be associated with mathematics. And so together, I tend to think of this as the idea of mathematical well-being. And we certainly know that while achievement and emotions tend to be related, right? So people who tend to experience really negative emotions around mathematics also tend to do less well in mathematics. We know that they're not one and the same. I probably don't have to convince you if you're here today that success in math is important, but if you need a little bit of a reminder, we know that, for example, at school entry, math skills are a better predictor of overall academic outcomes than our literacy skills. We also know that improved math skills are going to be linked to economic growth. That there is an increasing demand, for employees that are skilled in math achievement. So we'll often hear countries talking about having a STEM deficit. So the idea that we don't have enough students that are prepared to go into science, technology, engineering, and mathematics careers. And one factor that's going to be related to whether or not people go into mathematics related careers is this idea of math anxiety. So when I'm talking about math anxiety, I'm really just referring to feelings of fear, tension, apprehension that many people can experience when they're engaging with mathematics. We know that math anxiety starts fairly early. So children as young as first grade, so children around 6 or 7 years old, will report feeling anxious about mathematics, and that math anxiety seems to be related to their overall math achievement. Okay, so even at a very young age, students who are nervous about math or anxious also tend to do less well in mathematics. We know that unless specific interventions are taken, students that are anxious about math at a young age tend to remain anxious. Their anxiety tends to increase over elementary school and high school, and then peaks kind of, around late elementary school, early high school kind of ranges. So around age 13, 14 as when we tend to see the anxiety peak. And then it will continue on into late adulthood. So we've seen a few studies now where even senior citizens, so age 65 and over, who were math anxious when they were children, will report still being really anxious about math, and it can have some real life consequences for them. So one of the questions that my lab and many of the collaborators with whom we work have been really interested in is this idea of, well, how does math anxiety develop, right? Why is it that some people are really anxious about math, whereas other people are not at all anxious? Where is this coming from? And in my lab, we tend to work off this model that suggests that people who are anxious about math might start with difficulties in numerical or spatial processing. As a result of these numerical or spatial processing difficulties, these individuals are going to end up having lower math achievement. That lower math achievement can then result in math anxiety. If someone is anxious about math, then we typically see two sort of resulting behaviors. So on one hand, people tend to avoid math and they tend to avoid opportunities to actually hone their math skills. Okay, so if you're really anxious about math, you tend to not want to engage in any kind of mathematics. As a result, you're not really practicing the skills that you're going to need to succeed. This can, of course, feed into even lower math achievement, which can then feed into more math anxiety. The other thing that we see is that when people are anxious about math, they tend to experience negative thoughts and ruminations about the math. So often when we ask people, if you're really anxious about math, what are you thinking about when you're taking the math test? Typically, students will report thinking about the consequences of failing the test or not doing well. And it's amazing sometimes. So when we've interviewed students, it's amazing how to explain it. How quickly they can go from thinking, I'm not very good at math, to thinking, oh my goodness, this means I'm never going to get a job. My parents are going to be furious and I'm going to be living in a box by the river and it's probably not even going to be a nice box. And you can sort of see how these negative cognitions can snowball. And so from a cognitive science perspective, we know that when students are anxious and they're experiencing these negative thoughts and ruminations, then that tends to tie up working memory resources that are going to be important for doing the mathematics. So now what's happening is not only do people have to actually do the math test in front of them, they also have to deal with these negative thoughts and ruminations. So they're essentially in a dual task situation. Okay, so now if you're anxious about math, you actually have to do two things at once. And as a result, you tend to do worse in mathematics. And we're going to come back to this a little bit later when we talk about some potential remediations for math anxiety. The other piece of the puzzle that we think is really important is the idea of social influences. And so here I'm going to talk to you a little bit later about the role that parents and teachers can play in the development of math anxiety and about the development of math attitudes in general. So where did this model come from? Well, this is one that my lab and I have been working on for a while. And what I'm going to do is I'm going to show you how, trying to think of how to word this. See, I don't know whether you can tell, I'm still terrified about this Zoom meeting. So I apologize if I stutter at points. But yeah, so what I'm going to do is I'm going to walk you through some of the evidence that led to, the placement of these boxes in this model. So first, looking at the idea of numerical and spatial processing, in a series of studies that I did actually during my graduate career, what we did was we really looked at what we believed at the time to be the basic building blocks of more difficult mathematics. Okay, so we had undergraduate adults come into the lab. We asked them to do very, very simple tasks. So one was to count objects. So they would see a display of squares on the screen, and we simply asked them to tell us the number of squares that they saw. Okay. We recorded their speed and their accuracy, but it was not a speeded task in the sense that they were not pressured to go particularly quick. They were just told, go at your own pace, but try to be as accurate as possible. How many squares do you see on the screen? We've also asked participants to compare numbers. So they'll see either two single digits on the screen. So for example, a 7 and a 4, and they're asked to identify which is a larger digit. Or they'll see one number and they're asked to compare it to a standard. So for example, they'll see the number 3 and they're asked, does that represent a larger quantity than 5 or a smaller quantity than 5? And then lastly, we looked at some spatial skills. And so what I'm going to do is I'm going to quickly walk you through the results of these 3 paradigms. For the 3 studies that I'm going to present right now, these are all undergraduate adults. We're also always controlling for general anxiety in these studies. And in these particular studies, we took an extreme groups approach. So for this, what we did is we assessed participants' math anxiety early in the year. And then approximately 3 months later, they were invited into the lab based on their math anxiety scores. This was unknown to them, so they didn't know why they're being invited back in. And what we did is we invited in participants that fell within the upper and lower quartiles of the math anxiety distribution. Okay. So in the first study, where we asked them to when we asked them to identify the number of objects on the screen, the paradigm looked like this. So they would see a fixation spot for 500 milliseconds, and then they'd be shown a number of squares. And they saw anywhere from 1 square to 9 squares. Okay? And again, just asked to identify the number of objects that they see. So the results of this study, so to orient everyone to the graph, on the y-axis, let's see if I can bring a mouse over here. I can't. I'm apparently not technologically advanced enough to actually bring my mouse in. Oh, no, I can. Ha, sorry. Okay, so to orient everyone to the graph, on the y-axis here, we have response time in milliseconds. And then on the x-axis, we have the number of items that they saw. So anywhere from 1 to 9 squares. Our solid line represents our higher math anxious individuals, and the broken line, the lower math anxious individuals. And so what I really want to highlight is when there was anywhere from 1 to 4 items on the screen, okay, so in what we call the subitizing range, the high math anxious individuals and low math anxious individuals performed equally well. Okay, so there's no difference here. However, once we move up from 5 items to 9 items, what we're seeing now is the higher math anxious individuals are performing more slowly. Okay, I don't have the error data in this presentation, but the error data exactly parallels this. So what we're seeing is that the higher math anxious individuals are not only slower at being able to tell you the number of items on the screen, they're also less accurate. Next task, we asked individuals to compare numbers. So in this case, they were shown the single Arabic digit and they were asked to compare it to the standard 5. This is a separate group of participants. So people who participated in this study did not participate in either the first study or the third one that I'm going to show you. And here, what we see, so on the y-axis, again, we've got response time in milliseconds. And on the x-axis, what we have is what's called the distance between the numbers. Okay, so what you typically see is that people are much faster and more accurate at telling you which of 2 numbers is larger when the distance between that number is larger. Okay, so people are faster at saying that 9 is a larger number than 5 than they are, for example, it's saying 6 is a larger number than 5. And the idea is that we should be able to look at what we call this distance effect, okay, or the slope of a participant's response time based on these distances. What we should be able to do is look at that and get a bit of a sense of how precisely people are representing numbers in their mind. And so here what we're finding is that the high math anxious individuals, again, our solid line, they're doing this task more slowly than our low math anxious individuals. And the slope of their distance effect is larger. So the idea here being that the high math anxious individuals might have sort of a less precise representation of even these simple single Arabic digits. Okay, lastly, in this set of studies, what we did is we asked individuals to engage in a mental rotation task. And the mental rotation task is one that we were super excited about. The idea was mental rotation is something that seems to be related to mathematics. We're not completely sure why spatial skills seem to be related to mathematics. And that's something that my lab is currently spending a lot of mental resources on trying to figure out. But we know that people who tend to be good in mathematics also tend to be really good at spatial processing. There's some evidence that improving spatial skills can lead to improved mathematics. And one of the really cool things I think about spatial processing, at least in this context, is that it doesn't feel like math, right? So if we have people who are really anxious about math, the question was, would they also be anxious about this type of spatial processing? So if you were to do this task, what would happen is you'd see a display like this, and you'd be asked to identify which two of the four items over here represent rotated versions of this item here. And so I'm going to work under the assumption that everyone has already tried to do this in their heads. I will tell you that I'm awful at it, so if you get it wrong, don't feel judged. But in this case, to respond correctly, you would have to say that both B and C represent rotated versions of this one here. Okay, so what do we see? Well, what we saw here is that the low math anxious individuals, represented by the dark blue bar here, they performed better than our high math anxious individuals, okay? This is a paper and pencil task that we used, and so we don't have response times, we just have accuracies. And on the y-axis, this is their accuracies out of 24. So there were 24 potential items. In order to get any item correct, they had to get both of the rotated versions correct. So they had identified both of them. Okay, so as a quick summary here, I think there is a relation between math anxiety and performance, and it's not limited to just complex mathematics. Okay, so prior to this work, one of the thoughts was that you'd only see a relation between math anxiety and performance on tasks that were going to be really highly reliant on working memory. And that was the idea that, you know, if math anxiety is just tying up these working memory resources, then we shouldn't see a problem on tasks that are not particularly working memory demanding. But I think that this work at least points to the possibility that that might not necessarily be the case. We can see, I think, relations between math anxiety and performance on some of this more simple math. I think it also opens the door to the possibility that difficulties with numerical and spatial processing can actually predispose a student to develop math anxiety. Okay, and this is something that I think there's more and more evidence coming out to suggest this might be the case, that there might actually be reciprocal relations between math anxiety and math performance. So this is a large part of the data that led us to the development of this sort of component of the model. So this idea that numerical and spatial processing can lead to lower math achievement, which can then lead to math anxiety. So what I want to do for the rest of the talk today is I want to focus on this idea of social influences. And this is, in part, the reason I want to focus on this is where my lab is really going lately, and part of the research that I'm most excited about. So one question that we've asked is this idea of, can parents' math anxiety impact their children's math learning and anxiety? And if it can, is this going to be dependent on the frequency of interactions around math? So in this particular study, what we did is we focused on children in grades 1 and grade 2. And this represented the beginning of formal education in the United States where these data are collected. And the thought here was that if we look at the beginning of formal education, we might get to see a point where parents might have the strongest influence on their children's math achievement. So this might be the point at which teachers might have sort of less influence because the students haven't been in formal education for very long. We had 465 children, 258 of them were female, and their parents who participated in this study. In this, the vast majority of parents are female. So for the most part, I'm going to be talking about children and female parents or guardians. So what we did was in the fall, we went into the schools and we tested children in terms of their math and reading ability. So in terms of math ability, we used the applied problem subtest of the Woodcock-Johnson. And in this subtest, what happens is students are read aloud these word problems. They often see images associated with the word problems, and they're asked just to provide an answer. Okay, so you might see, for example, if you have 7 pennies and you spend 3, then how many would you have left? Okay, and the child would be seeing the picture of the 7 pennies here, and they would just have to give a response. So the way this test works is you start with simpler questions, and then you keep progressing with more and more difficult questions until you get to a point where the child is getting X number of questions in a row wrong. And the idea is that it allows you to really to get a sense of the child's maximum level of mathematics achievement. We also conducted a reading parallel. So here we use what's called the Woodcock-Johnson letter word identification. And here the child would see a series of words on the page, and they were asked to tell me what the words are or just to read aloud the words. And again, similar to the math, what happens is these get progressively more difficult. So you really get a sense of the child's sort of upper level of reading ability. Then in the winter, we assessed parents' math anxiety. Okay, so we did this using the abbreviated math anxiety scale, as well as the mathematics anxiety rating scale. And so they were just asked to rate, for example, how much anxiety would you feel calculating a tip at a restaurant? We also asked parents to report on the frequency of their homework help. This was to try to get a bit of a proxy for how frequently parents are interacting with their children around mathematics. And then we went back in the spring and we re-administered the applied problem subtest of the Woodcock-Johnson as well as the letter word identification. And the idea was this way we can get a sense of how much the children are learning over the course of the school year, so we can look at their growth. And so what I'm going to tell you, any of the results that I'm going to show you from this study, we're always controlling for reading ability. Okay, so anytime I talk about math growth, we're also controlling, for reading growth. So, first question, was there any effect of parents' math anxiety on children's math learning at all, right? So specifically what we're wondering, were children whose parents higher in math anxiety, did they tend to learn less math over the school year? And what we see is maybe a little bit. So on the y-axis here, to orient everyone, we're plotting what's called grade equivalent change. And this is a standardized score that you can get from the Woodcock-Johnson. And it's essentially just giving us a sense of how much the kids are learning over the school year. Okay, so over one academic year, you would expect the average child to learn about a 1. Okay. And then here we're looking at children whose parents are lower in math anxiety versus children whose parents are higher in math anxiety. And what I will say for anyone on the call who's interested in in the stats behind this, I'm presenting the data here broken up into groups, so I've dichotomized it just for presentation purposes, but all of the analysis that we actually ran were all using the variables continuously. We did HLM to control for the fact that children in one class are going to be more similar to each other than children across classes. Yes, and we're also, sorry, the way we calculated growth was always doing spring achievement controlling for fall achievement to take into consideration that children are not all starting at the same level. All right, so then we asked, well, what if parents are helping frequently with homework, right? What happens if parents are really involved with their children? Would that provide more opportunities, for example, for children who are anxious about math to sort of convey that anxiety to their students or to their children? And this is exactly what we see. So what I'm showing you here is the parents divided up into those who helped less frequently with math homework versus those who helped more frequently. And what we see is that when parents don't help very often with their child's math homework, it doesn't really matter whether the parents are higher or lower in math anxiety. The children are still going to learn statistically the same amount. However, when parents are higher in math anxiety, when they help with their children's math homework really frequently, then what we're seeing is that the children are learning less math over the course of the school year, than are their peers whose parents are either lower in math anxiety or their peers whose parents are higher in math anxiety but just don't really help with homework. Okay, so then the next question was, does parents' math anxiety relate to children's math anxiety? And here what we see is that, yes, it does. So parents' math anxiety leads to children's end of year math achievement. So when parents are higher in math anxiety, the kids are learning less math. When the children learn less math, they end up becoming more anxious about math. But this relation is only true when parents really frequently help their children with their math homework. Okay, so there really seems to be something going on during that interaction period that seems to be leading the children to be learning less math over the school year and then also developing more anxiety. And so I think parents' math anxiety matters. For the higher math anxious parents, the frequent homework help is negatively impacting their children's math achievement as well as their math anxiety. And I think one of the things that came to mind when we're doing this research is the idea that parents are consistently urged to help their children with their homework, right? And I would argue probably no more so than right now during the current pandemic, where so many of us have all become homeschool teachers as well as whatever our other jobs have been. And so I think it's not enough just to tell parents to get involved, right? I think rather that as researchers, we really need to help. We need to work with educators to really develop tools to scaffold parents' homework helping behaviors, right? It's not enough just to assume that everyone knows something about math pedagogy and then tell them to help their kids. Instead, I think it's really important that we're working together to help develop these sort of scaffolding tools. So this leads us into where my lab is really going lately. And so one of the things that we've been really, really interested in for the last couple of years is this idea of, can we help, right? What can we do to help parents better help their children? So the first time that we asked this question, we asked particularly, can an iPad app, so specifically bedtime math, can this improve the quality of parents' math-related instructions with their children? Okay. And specifically, if it does, would this be more effective for higher versus lower math anxious parents? And so in this particular study, we used what's called the Bedtime Math app. So this was an app that was already existing, and it was designed to be used by children with their parents. Okay, so it's not really a set it and forget it app. It's one where the parent and child are going to be using this together, interacting. So in this app, the parent reads a story to their child, and then together they answer a series of questions that are related to the story. The app is designed to be fun and interesting for children, but it was also designed to have very few bells and whistles. And so the idea is that it was designed to not be distracting to children, but engaging enough that they're going to want to play it. The app was also aligned with the US Common Core. So the idea here being that all of the math questions that are going to be asked in the app are going to be developmentally appropriate. Okay. So this is a screenshot of what the app can look like. This app is free to download, so if anyone wants to go and check it out, you're more than welcome to. But the way it works is the child would see this story. It's designed to be at a reading level that's too difficult for the children to read it themselves, so the parent has to read it. And so they may read, for example, this story about whipped cream and how it was invented. And then after reading the story, they would get a question. So for example, if you can whip 2 cups of heavy cream into 6 cups of whipped cream, how many cups of air did you whip into it? Okay, so here the child and the parent would work together to solve the problem. And there's also the problems can get significantly more difficult. So for each of these, there's 3 levels of difficulty. We also had a reading parallel. So what would happen in the reading parallel is that the child would see a very similar story, and then rather than being asked a math-related question, they'd be asked a reading comprehension question. And the idea here is just to make sure that if we see any impact of the math app, we want to make sure that it's about the math content specifically and not just about the idea of, you know, being given an iPad or maybe parents and children spending more time together. So again, these are going to be children in grades 1 and 2, so 6 to 8 years old. And what happened was in the fall, we administered the iPad. So everyone in the study was given an iPad mini with the app pre-installed on it. One of the really cool things about using the app is that it can track all of the information. So we could track whether or not anyone opened the app, when they opened the app, for how long, what they did with it. Some of the parents consented to having their audio recorded as well. So that's data we haven't gone through yet. But again, the idea with the app is that you can get some really, really rich data. So I think it's a fantastic way of going. Maybe even more relevant now that many of us are doing research from afar, or at least trying to figure out how to do research from afar. Also in the fall, what we did was we administered those same 2 subtests of the Woodcock-Johnson that I told you about earlier. So the applied problems to assess mathematical ability and the letter word identification to assess reading ability. We also tested the parents in terms of their math anxiety. Then in the spring, what we did is we went back into the schools and we re-administered those fall measures. Okay, so we again have the children's math achievement across the school year, as well as reading achievement across the school year, and we have their math anxiety. So the first question that we asked is, did the app work, right? Is there any benefit to having used this app? So what I'm going to show you next is I'm going to show you, well, here, I'll show you. So this is looking at math achievement across the school year. Okay, so that same unit that I used before, the idea that students should be learning at about a 1. This is the amount that students learned in math if they got the reading app, okay? And what we see is that students who got the math app learned significantly more math over the school year than did students who got the reading app, okay? We next asked, well, what happens when higher math anxious parents use the app with their children? So here, what I'm showing you is we've divided the data up into no use versus use. So one of the not not devastating because it's not maybe that big of a deal, but when you are a postdoc and working on this kind of stuff, it felt devastating. So I'm going to use the word anyway. So one of the devastating consequences in this study is that there were several parents who got the iPad. They and their child got the iPad, and they just never opened the app ever. And so when we were hoping that they would do the app together, this was a little bit devastating, but it also resulted in sort of a relatively cool comparison group where what we could do is we could look at these children because we still had the children's performance scores over the year. And so we consider this to be sort of the business as usual situation. And so here what we're seeing is, again, when children's parents are, So when the parents are lower in math anxiety, the children are learning more math over the school year than children whose parents are higher in math anxiety. But I think what's really interesting is that this is no longer true when the parents and children are using the math app. So here what we're seeing is that use of this math app really seems to be closing this gap that's caused by parents who are really anxious about math. Okay, so why did the app work? So we have a few ideas of why the app might have worked. One of them is, I think the app provided parents with sort of a scaffolded way of helping their children, right? It gave them an instruction on, here's a way in which you can interact with your child around mathematics. And we think that as a result of doing that, it probably also led to a lot more informal math happening at home as well. So the assumption is that it was probably the case that these parents, when they had a way of interacting with their child around mathematics, they would then, even in informal contexts. So for example, maybe when they're cooking, they can start talking with their child about fractions or temperature or time. But again, these are hypotheses, right? These are things that need to be tested. And so one of the things that we're working on in my lab right now is really trying to figure out what's happening during these math interactions. So in a study that one of my PhD students ran, she was really looking at the role that parents' negativity might play, looking at, parents' negativity of emotional experiences during math homework helping. So what she did is she surveyed parents of children in grades 1 through 6. So these are children across North America, so Canadian and the US. She had 205 parents respond. And she was just asking them, how confident do you feel about helping your child with their math homework? When you help your child with their math homework, how stressful is this interaction? How much conflict is there between you and your child? How frustrating is this interaction? Right? What she was trying to get at is really get a sense of what's going on, right? What does this look like? So when she's asking these questions, she is also controlling for generalized anxiety, and she's also controlling for math knowledge. Okay, so she has the parents do an actual math test to get a sense of their math skills. And what Michaela found was that when parents are really high in math anxiety, they tend to experience more negativity in the homework interaction. So they report that they have more yelling, more tension, more frustration. They find the whole experience just overall more negative. So just to give you a quote, so we asked parents just to explain, in their own words, what these situations are like. And of course, I cherry picked one of my favorite ones here. But this particular parent wrote, we find working on homework very stressful. My daughter has an I will never understand this mentality about math, even when she's succeeding in class. And she gets very worked up when there's homework we need to do. There's a lot of emotional management required on my part. So as I said, I cherry picked this quote, but I did it for a few reasons. One, I think it actually gives a fairly representative description of what many parents reported. This idea that, it's a negative sort of frustrating experience where the parent is doing a lot of this emotional management. But I also wanted to highlight this idea here that the child seems to be having this negative emotion, even when they're doing well in mathematics. And so I think this brings back to the idea, or this comes back to the idea of mathematical well-being being more than just, achieving academically. It's also the emotions and attitudes that are going to be associated with math as well. Okay, so these particular studies really lead into this idea of the social influences being at play in the development of math anxiety. So again, just to give you an overview of the entire model, I think that math anxiety it's a relatively complex issue. I don't think that everyone who's anxious about math is going to be, I don't think it's a homogenous group. And so there are different reasons why people might be experiencing anxiety. But I think that a lot of the time we're going to see that, it's people who are experiencing difficulties with numerical and spatial representations that are going to lead to lower math achievement. And you can see where this then gets you into a bit of a vicious cycle. And I think that the social influences are going to come into play as well. So these social influences might even be particularly strong for children who are already struggling, right? There's certainly a lot of negative attitudes about math in our society in general. And so it may very well be the case that children who are already struggling with numerical or mathematical processing might be more prone to pick up on those negative attitudes and to really start endorsing them themselves. Okay. So again, just highlighting this idea that in my lab, we've really been thinking about mathematical and scientific well-being, right? So I think math is important, and mathematical well-being is more than just achievement, right? So attitudes really matter too. That there are both these cognitive and social factors that are going to be involved in the development of math anxiety, and that there's evidence that interventions might work, right? So one of the things that I wanted to mention, one of the things that I wanted to mention is that there are a number of really, really interesting studies that have come out looking at ways that we can either we can help students to decrease the amount of math anxiety they're feeling, or we can at least sort of break that link between math anxiety and achievement. And so there's been some really cool work looking at the role of expressive writing, for example. So this is an intervention that I absolutely love because it's really low cost. But the idea is that you can have students write about how they feel about an upcoming math test for about 10 minutes before they do the test. And that as a result of the writing, the students tend to do better on the math test. And one of the thoughts is that while they're writing, it allows them to reappraise the situation. So it allows them to get from, I'm feeling really nervous about this situation. If I don't do well, my parents might get mad at me. To kind of go through the thought process to more of a, but you know what, I've been studying, I've done well in the past. I've maybe heard this idea that girls are not very good at math, but I know that's not true. Hey, I think I've got this. And all of a sudden they're in a place where now they're ready to approach the problem as a challenge that they have the capabilities of achieving, rather than, thinking of this as a threat that they just don't have the ability to handle. So in that sense, I think the expressive writing is a really interesting intervention. Gerardo Ramirez and Sian Bailock have done some really cool work with this. Annie Park has done some work with math anxiety specifically with expressive writing. There's also been a number of other interventions that seem really interesting. So even just the idea of having these anxious students do math-specific tutoring. So Vinod Menon has some really cool work showing that a tutoring intervention helps students to bolster their basic math skills. As a result, they end up feeling more confident. And you can see where just like math anxiety can lead to this vicious cycle where it can cause you to do worse, I think these achievements can also help break that cycle and result in a more positive version of it where, you do well, this leads you to be more confident, which then can lead you to do even better. So I think while I certainly argue that math anxiety is an issue and one that I think is worth paying attention to, I think some of the good news out there is that there's certainly been some work done to suggest that there are going to be ways that we can combat this. Okay, and then the very last thing before we move into the Q&A is I just want to do a shout out to my lab. so, you know, as I'm presenting the work here today, it's certainly by no means my work. It's always a group effort. So some of the more recent stuff that you would have seen, my graduate students have been really heavily involved in. And then some of the other stuff that I mentioned was work that I had done while I was a postdoc with Sian Bylock and Susan Levine. So their labs obviously played a major role in all of that research. And then also just a quick thank you to the funders of this research. So funding from the Natural Sciences Engineering Research Council of Canada, as well as the Social Sciences and Humanities Research Council of Canada. And in the center of this picture is a very valuable lab member. This is, let me see if I can find my mouse. I don't need to point it out, he's the dog. So this is Winston. So Winston is my guide dog. Because I am someone who is legally blind. And so Winston plays a major role in boosting lab morale. And in fact, I think we end up having participants come into the lab in part because they hear that they get to pet a puppy. So we're okay with that. Okay, so Andy, that's all for me. So I think if you want to do a Q&A.
Yeah, thank you so much. And if I've taken nothing else from this, it's that I feel like there's good reason to start bringing my dog into the lab. Hopefully everyone's labs will be okay with that as well. Thank you so much for a fantastic presentation. So as we move into the Q&A, I would love if people could identify themselves in the chat, and then we will ask you to ask the question yourself. As people start to type out their questions or introduce themselves, I just want to thank everyone. I realize that we're running a little short on time, in part because I rambled a bit at the beginning. And I'm going to ramble again right now as people start to type out their questions. I feel so incredibly thankful for this community of scholars as a part of the MCLS, that we had over 100 people here from at least 10 countries that I just know personally. I feel like this kind of organization, the MCLS organization, is such a unique place where we can gather over 100 people in 10 days to talk about our friends' work. So, Bert, did you want to start off with a question?
Yeah, sure. Shall I put on my video or?
Yeah, great. We love to see your face.
Okay, so I'm not sure if it should be working right now. Okay, so Erin, that was a great talk. I highly enjoyed it. I really liked the different set of studies that you have presented and the model that you started from. I like it when you can combine those different types of factors to study this important phenomenon that is likely to be influenced by various variables. I had a question on the role of parents' own abilities and how that goes into the research you presented. In the first studies, or at least the first part of the talk, the abilities of the parents were not mentioned, but then in the last study you presented, you measured their math knowledge and you put it as a control into your analysis, but I was curious to see to which extent that was related to their math anxiety and their activities related to the homework, for example.
Yeah, so I think it's a really good question. In the first studies that I talked about, so the data that I showed you was not controlling for any sort of parental math ability. We did find that the results still held if you controlled for parents' highest level of education, as well as number of math classes taken. So those were sort of rough proxies, right, for math ability. But I don't think in that stuff, we never specifically looked at whether parents' math ability itself played a role. In the later work, again, we've used it as a control. The relation between parent math anxiety and their own math achievement was about the same that you see with undergrads. So it was around like a correlation of about 0.4. But no, I think that's a really good question. And I can get back to you because I should probably look at it. Sorry, I haven't looked at it yet, but that's
No, I mean, I think it's just it's maybe just something interesting to have a look at, because I mean in the beginning of your model you were pointing to an association between ability and anxiety, and it could also work for the parents. So um,
yeah, no, I agree. I think that's a really good point, and I will absolutely look at it because I don't have the answer, and I feel like I would like to know it. So
yeah, I'm
yeah, thank
curious.
you. Yeah, no, I'll let you know. Thank you.
Great. So for our next question, someone messaged me privately, Ruggiero. I'm not sure if I'm getting your name correct.
Yeah. Andy, can I stop? I can stop sharing my screen, right?
Yeah, that would be great. Then we can gallery view.
Okay. Is that better? I feel socially awkward. I'm sorry. Yeah.
I am socially awkward, so that's fine.
I feel like academia is an area we're allowed to be socially awkward, so it's okay. But
okay, hello, this is me, Ruggiero. Yeah, it was almost fine. Sorry. So hello, I'm a PhD student that's studying mathematics anxiety. And well, my first question was actually the same that Bert did. So he preceded me, but I also was wondering if you looked if parents' mathematics anxiety has a direct relationship with the children's mathematics anxiety, because we saw that the children were either better or worse in mathematical performance, mathematical achievement. But if the parents' mathematics anxiety directly influenced their mathematics anxiety or not. Did you look at this?
So we have I've looked at it. We have some really preliminary data on this. Take it for what it's worth in the sense that this is super preliminary. But one of the studies that we're doing right now is to try to understand what's going on during those homework interactions. We've up until March of this year, we had parents and children. So these were children, 10, 11, 12-year-olds. So we had parents and children coming into the lab and actually doing math homework together. And we were looking to see what was going on in those interactions. And we coded for the positivity or negativity of those interactions based on just the positivity or negativity of the words used by the parents in the interaction. And there, what we were finding was that parent math anxiety was related to child math anxiety, such that, the more anxious the parents were, the more anxious the children were, but that this was mediated through the overall negativity of the math interaction that they had. That said, we ended up having to have a much lower N than what we were hoping for. So that was with about 40 parent-child dyads. So I think it's definitely something that we're interested in and trying to figure out the best way to follow it up. So I think there's probably something there, just the exact nature of it, I don't know yet.
Did you check also for gender interactions? I mean, I remember female teachers passing math anxiety to the female students, but not male teachers passing on, so did you check gender interactions?
Yeah, so we yes and no. So, well, no. So yes, we were looking, but no, we didn't really have enough power to detect anything if there was anything. The other thing that I'm going to do is, so that work that you're talking about with the teacher's math anxiety relating to the kids. So that one, it's actually a little bit more subtle than that. So it's the teacher's math anxiety. We've never actually found evidence that it causes children to be math anxious. We found evidence that when teachers are really anxious about math, then the children learn less math over the school year, right? And they tend to have more negative attitudes about girls and math in general. But it wasn't the case that the girls' math anxiety, or that the female teachers led to increased girls' math anxiety. Yeah, that one, sorry, I know that one's always, it's like this really subtle little thing. Yeah. But I find, I mean, it's the kind of thing that I spend so much time thinking about, right? So it's one that it's on my mind. The other thing I will say is in the study with children in grades 1 and grade 2, there you saw that, so parents who are higher in math anxiety, their so yeah, when parents are higher in math anxiety, the children learn less math over the school year, and those children end up becoming more anxious about math themselves. But again, that was only when the parents are frequently helping their children with the math homework. Yeah.
Okay, thank you.
Great. Parnika has a question on social and cultural influences.
Hi. Thank you so much for the talk. It was really, really insightful and also like really easy to follow. So I am a second year PhD student in France, but I belong to India. And so most of the times, like we all know in research, we see a lot of studies are done on the weird population. And that brings me to my question about social and cultural influences and whether there have been studies that have been done on math anxiety and student and parent population from Asian countries. And it might have, I don't know whether it's true or not, but I know from personal experience that math achievement and being good and bad at math is a lot of societal pressure in India, where I come from. And sometimes I feel that anxiety in math can also lead to better performance. But I'm not really sure because I don't know of any studies. But what do you think about it? And are there any studies on populations other than the weird sample? Thank you.
And there's actually a lot to sort of say about it. So I'll try to give a concise answer. And then if you're not having the answer, just send me an email to try to elaborate.
Well, I guess her fears came true. It seems like we might have lost Erin.
Yeah.
Okay, it seems like she's back. She just rejoined.
Okay, sorry, can you hear me now?
Yep.
See, this is the fear, right? This is the anxiety about the internet cutting out and give it 5 minutes. My kids are gonna come running through naked, I swear. This is my dream. Okay, so your question, I think is a really good one. There has been some work looking at the relation between math anxiety and math achievement using OECD data. So there, what you see is that in every country studied, and I think it was 69 or 70 countries studied, what you see is that there's a negative relation between math anxiety and math achievement. So that's one piece to suggest that, you know, this doesn't seem to just be a weird problem. That said, I think that you're probably bang on with the idea that there are going to be social cultural factors, right? So there's some work that I've seen, and I apologize because I'm blanking on who conducted the work, but looking at in Asian countries specifically, looking to see that math anxiety there seemed to be more strongly related to test anxiety than what you were seeing in North America. So it might have been a little bit less about the math and more